Everything is going okay. I should be live right now. It can be that my stream is a little bit delayed. I've been tweaking with some settings around like bit rates and stuff like that. So some feedback around that would be appreciated. So if you could... All right, I see good audio, good video. So that's nice. All right, let's give people a couple more minutes to start, and then I guess we're off. I am live. Well, it's already nice to see so many familiar faces in the chat, so that's cool. Maybe I should bring my chat screen up with the rest of my stuff so I just look in the same direction. Tell us a joke. God damn it. Jokes on the spot is not really my forte. Let's see if my tweet made it... Nope, my scheduled tweet did not go out, but that's okay. Let's just start. All right. Well, hi everybody. My name is Frank, and I'll be talking a little bit about implementing event sourcing today. It's a topic that I really like. I like applying event sourcing, but I do notice that a lot of people are sometimes struggling with some concepts, and there's a lot of jargon, there's a lot of things going on in that space. So I figured I'd create a presentation around this. I've got about like 122 slides prepared, so strap in, we're going to be here a while. All right, there we go. My name is Frank de Jonge. You can just call me Frank, that's fine. I'm the guy that made Event Source and Fly System. Fly System is probably something you already know, and maybe Event Source is something new to you, but then again, you're here in an event sourcing talk, so maybe this is already known to you. It's a library to get started with event sourcing. Well, not only to get started, also just to use it, but it's an easy way to get started using event sourcing. In my day-to-day job, I work at Molly, and we're a payment service provider. So that means we process payments online. We do this in PHP, and yes, we are hiring. But enough about me. Let's talk about technology that I like. I'm seeing some happy birthday remarks. Well, thank you, people. Thank you. But back to event sourcing. If I think about event sourcing, especially the journey that I took in order to be able to understand it, and also looking back at it, I can say that event sourcing itself is not hard, but learning it is. If you would describe event sourcing in one sentence, it would be like, event sourcing is a technique where decisions are made on past events, resulting in new recorded events that are stored for later decisions to blah, blah, blah. And at the first time I was delving into this stuff, I was more like this, right? It's like, what the hell is going on? So, of course, that's not really what I want for you. So I'm going to try to make it more like this. So I'm going to try to make this a sort of event sourcing, how it's made. And for that, I will combine some theory and some perspective on how I look at event sourcing. And maybe this will help you to get a better or some understanding around the topic. Or maybe some clarification if you already know some things. If I would describe it in the simplest form, event sourcing is a way to create software models using events. And the thing that makes it hard is that if you look at all this, there are a lot of concepts, and there's also a lot of jargon about this. So during this presentation, I will go over all these concepts. So if you want to be a resume-driven developer and speak the lingo, put some skills on your LinkedIn profile, I hope that by the end you'll be able to do so. And I want to do that based on an example. Of course, I work in payment processing, so everything regarding expenses and paying stuff is really natural to my domain. For you, it might be different. But if you look at the way we implement business logic, it's mostly the same. We have some context, like here we have a credit. We want to make a purchase of 80. We check if there's enough credit. And if so, then we make the purchase. Every time you see a red icon in the top left, this means you can actually execute this. So I'll try to remember to push this button as much as I can. So if the credit is 6 and we want to make a purchase of 80, well, we can expect what happens. The purchase of 80 is failed. But of course, this is not really real life. We have some way to retrieve the credit mostly. So now I've replaced it with a random number. So you can see, I'll do it a couple of times over. If it's high enough, it will be okay. And now I want to see, like, all right, now it's lower than 80, so it's failed. But of course, the same is true for the purchase. So now we've got randomized values on both ends. And you see that the logic is just basically the same, right? This is our how we do things. We have a given context. We have some input. We make a decision, and after this decision, there's an outcome. So if you look at this and put this in a general context, then you could say, in a given context, when handling input, a decision made which has an outcome. And this is true for so many things. So of course, we don't write procedural code. We use object-oriented code, so we have a class to represent this. So if you look at traditional CRUD type implementations of this, you have some kind of personal budget and there's a spend method on it. So if you use this, either you use some kind of ORM or a database repository to retrieve the personal budget. So again, you've got the same kind of thing here. You retrieve the personal budget, which is the context. Then you have a decision based on input, and in this case, that's the amount to spend outcome. This would normally, of course, be something that you get from your request object or some kind of input getter. And at the end, we've got some outcome, and the outcome could be direct outcome, but it could also be, it's also the fact that we now persist this and that the new state is now the state that we live with. So if you look at this in an abstract way, you could say that we have a state, and this state is something that we persist in the database. We then perform an action which results in a new state. And then we store this state, which means the old state is effectively gone. But that also means that if we don't have this old state and the new state, we effectively don't know how we got there. So we're only left with a new state. So we load the model from the database. And then we interact with the model, and then we persist the updated model. And this is what we're used to, and this is normal CRUD. I also want to stress that there's nothing wrong with CRUD. But if we look at event sourcing, this is different. We rebuild a model based off of stored events. We then, as you would expect, interact with the model and then store the changes in the model. If you put this in event sourcing jargon, people call this reconstitute the aggregate from old events, interact with the model, and then persist new events and dispatch them. So if you look at that in a diagram, it starts to look a little bit different. So we have a state that we start out with. Then we perform an action, and this action results in an event. This event is something that we store. And every time we have another interaction with this model, we just have new events. And we also use those events to reconstitute the model. So whatever we've got in store will influence the state that will influence our decision when we do an action. So now, in order to start implementing this and to get all the theory in our head and look at it in practice, we should look at some terminology. So the first group that I want to address is the event, the aggregate root, and the aggregate root repository. So the event is basically the core thing. If you look at an event, that's a representation of a historical fact. That's something that happened in the past. So since you can't change history, this also means that you need to implement it in a way that respects that. So it makes sense to make this an immutable value object. If you look at this is basically a class, and a class is responsible for representing an event. So in this case, this class represents the fact that a purchase was made of a given amount. So everything that's in the constructor is basically the context that's associated with the intent that's described in the class name. Usually you'll see some serialization stuff come here as well. So what you see sometimes like a to payload and from payload kind of setup. And then you can see that these value objects are basically just representing values. So if you have an event of a purchase was made with 150, you extract the payloads and you recreate the event from that payload, and then you can say that these are not the same, but they are equal. And to prove that, I will run the script, and you'll see it's not the same, but it is equal. So the next concept is the aggregate root. And the aggregate root is the way that we interact with our domain. One important aspect of this is that it's limited by a consistency boundary. So whatever needs to maintain consistent, and these are our business rules, if we draw a circle around these things, then this is our consistency boundary. So that means the way that we access must be through one unified way to make sure that everything within it remains consistent. And a good analogy, I think, to describe this is a car. If you're operating a car, or if you're driving a car and you want to take a left turn, you don't do this by taking the individual wheels and adjusting them. You do this by taking the steering wheel and turning that. So there you see the effect of having an interface, and the steering wheel is effectively the interface that you're operating a car with. This is how you make something consistent. So in PHP, this looks something like a class. So if you have something like a personal budget, you can construct it with an ID, and then you can increase the budget with a given amount. And in traditional CRUD, you would immediately manipulate a property of a class. In event sourcing, everything is all about events. So how does that work? So in an event-sourced way, what you start off with is recording an event. And this event is recorded upon the aggregate itself. That's implemented here in a method called recordThat. If you look at that implementation, it does two things. One, it applies the event, and we'll go into what that is later. And then it records the events. If you look at the application, that's basically it's implemented as a sort of utility function that makes sure that the corresponding function is applied or is called with the event. So the apply budget was increased method is called, and it has a payload which is the event budget was increased. And here we do the manipulation. A fun thing about using event sourcing is that you cannot only look at everything that is right. So if you look at this is again a CRUD implementation. If we turn this into an event sourced one, we record that a purchase was made. So here you see there's a decision being made that results in some recorded events. But what you normally do in a CRUD-like system is that you only capture if something has gone right. Well, in event sourcing, you can capture what is right, but you can also capture if there was something wrong. So, for example, if you want to limit overspending and then notify when somebody is going over budget too many times or too early in the month, you can record events of things that quote-unquote failed. So if you look at interactions with software that way, there's a wealth of information that could be captured if you focus not only on the positive sides but also on the negative sides. So if you look at a model like this, you can already start to see that this is an internal affair. If you look at the interactions with a budget, everything is external, and you don't see event sourcing stuff. So that's it is not a let's say a concept. It's not a top level design. So it's an implementation detail, and you can just assess the state of the aggregate from outside, like we're doing right now. Increasing the budget with 50 and with 100, can I spend 75? Well, yes, you can. Can you spend 100 now? Well, no, you can't, right? If you look at what this results in, all these things just basically translate to events. So the last thing was a budget was increased, purchase was made, and now the outcome is budget was insufficient. So, of course, now that we've got these events recorded, well, if we don't do anything with them, they are lost. So now we're going to move on to the next section. For the next section, we need to be able to expose the events that we've recorded internally, because we, of course, want to persist these. For that, we use an aggregate root repository, and this is responsible for storing recorded events and reconstituting aggregates. So that would just be maintaining the life cycle or managing the life cycle of an aggregate root in terms of persistence. An interface for such a thing can be very simple. The only thing that it needs is a persist method and a retrieve method that loads and stores an aggregate root. If you look at an implementation of that, for the persist method, the events can be found through the release events method, and the aggregate root ID can be fetched as from a getter from the aggregate. We then want to wrap everything in messages, and messages are basically the envelopes of where the domain event is the letter. And you use this kind of a wrapper to, one, give a unified structure, but also to be able to associate any other metadata. And we'll talk a little bit more about that. So the last bit is where we persist it in a repository, in a message storage, and we send off the messages for dispatching. So now we've covered the first three concepts. We already peeked a little bit ahead into the next one, next three, and the next three are around this storing of messages and dispatching of messages. But what is a message? So a message is something that is recorded in the aggregate, or the events are recorded in the aggregate, we send them to a repository. This is where they are converted into messages. And then the last step, we say, we send these messages to the messages repository and to the dispatcher. So what's a message? A message is a wrapper to contain additional metadata. So by default, especially if you look at the event sourcing frameworks, these contain the aggregate route ID, perhaps an event type, perhaps some other standard metadata like the time of recording of an event, and so on. You can also use this for tracing. For example, if you want to know what system a message originated from, well, you can decorate messages with additional metadata in order to store this information. And this information is more like a side concern. So your domain is not really interested in those technical details. And this is why the message is something that is more for everything that consumes it and sort of the infrastructure around event sourcing itself. And if you look at the aggregate, it's really focused around only these events. So if you look at the message, the structure is pretty simple. So there's just a event object, and there's an array of headers. And this can be serialized to JSON, and then you get something like this. So here you see the aggregate route ID and the event type. Here it's converted into a non-PHP class name kind of thing, but you can basically translate this into anything. At the bottom you see the payload, and here you see this was a purchase was made event of an amount of 80. Here you also see the cost by thing, which is an example of using IDs to correlate some actions. So for example, if your commands have identifiers that you can use to correlate what kind of events are associated or what kind of events were caused by this command, this really helps your debuggability in especially larger systems. So that's something that you can think about. So of course you need to store it somewhere. Well, for this you need a message repository, which again is just responsible for persisting and retrieving messages. It's very simple, and it can literally be anything like MySQL, MongoDB, Redis, if you don't care about data loss, whatever works for you. Cassandra is also something that you can contemplate using. If you want to use MySQL, even a small table like this or a table definition like this would already be sufficient. So here you see we just need the aggregate route ID and the payload, which is a JSON column for this to work. Of course, we index it for aggregate reconstitution. We want fast lookups that are ordered, so we use a big int in order to make sure this ordering is applied. If you want to look this up, that's of course the other end. Inserting is probably simple, but you can just use a where clause, and this is something that when I first started looking at event sourcing, I heard, well, you need to reconstitute it from all the events. And then I thought, well, do you really need to have all the events? But this is where the consistency boundary makes sense. So you only need the events that are associated with a particular aggregate route ID in order to make your decision. So that's what you can limit this by. For the dispatching, this works a little bit differently. The interface is even simpler. There's just a dispatch function that dispatches messages. And the implementation of this can be, again, literally anything. This could also be, something like RabbitMQ, Kafka, but you could also make an in-sync variant of this. So a synchronous message dispatcher would look something like this, where it will have a reference to whatever is interested in the particular events in its constructor, and whenever it receives messages to dispatch, it will just loop over the messages and pass all the messages to the consumer. Of course, this has some upsides and downsides. The upside of this is that there's no extra infrastructure required. And for a lot of things, it's good enough. If you have database projections that you want to keep in sync with your aggregate root, a strategy that sometimes applied is to decorate your command handler with a database transaction and actually wrap that transaction all around the interaction with the model and the dispatching to the consumers. In this way, if one thing fails, everything fails and the entire transaction is rollbacked. Of course, this is also immediately the downside. There are no retry mechanisms, there's no horizontal scaling, and you don't have easy rebuild of projections. If you look at the asynchronous stuff, well, this implies, well, now you need extra infrastructure, so it's a more complex setup, but you do gain the fact that you can retry. Reads now all of a sudden can be a lot more scalable, and I'll talk a little bit more about that later, and rebuilds are possible. So now we've got the middle chunk, and the last chunk we already explored that a little bit, or at least touch upon some concepts. So now let's dive into them. We'll start with the consumer, and the consumer is just something really simple. A consumer is something that reacts to events. A consumer interface is also pretty simple. It is just an implementation of the consumer, or an implementation that has one method, which is the handle method that accepts a message. If you then look at a projection is just a type of a consumer, but it has a particular job, and the job is to use the event data to create a read model, a view. If you then look at what is then a read model, well, a read model is a view of the event data optimized for reading. Let's make that a little bit. Let's illustrate that a little bit. If you have one aggregate, so here we have the aggregate A. So this could be my personal wallet. There's a couple of events associated with that, and these combined form a stream. But if you look at dispatchers and the consumers, they don't just consume events of one particular aggregate root. They get the events from everything. So you get events for multiple aggregate roots, and given the aggregate root, it will be in a different time frame altogether, but it will be a full view on everything that is happening. So if you look at a view, you could use one or more of these events to create a projection. So for example, if you want to get a detailed view of a particular aggregate root, for example, my personal budget, I want to get all the transactions out of that. Then for one personal budget, I can create a view that is based around all my or all the C events, for example. But I could also do a list view. For example, I want to list all the personal budgets that I have for example, my family. Well, this is where you look at multiple aggregates and the same type of events. For example, here I want to check to see for a personal budget was created event to hydrate them, to add them to the list. Of course, you can mix and match these things. So, for example, if you want to remove every personal budget from the list after all the purchases have been done and there's no money left, and we want to dispose of a personal budget, this is something that we can implement by basically looking at two types of events, and everything in between is possible. So if you then look at the implementation of this, is just a class that implements the consumer interface. Of course, this needs some kind of persistence to back it. But for example, if we have a way to store the spend per user, we can just look at all the events that are of purchase was made, and then we use the information inside that event in order to project this data. In this case, that would be a most spent list if you want to calculate a top spending list forever, for example. You can also make this a little more elaborate by getting some information from the message. So for example, here we want to get the highest purchase list per month. So you can flesh these out and you can create more elaborate constructs, if you will, just by inspecting the events and using the data that's inside these events to create views of data that are optimized for reading. And that's the essential thing here. If you look at these, what is created in these kind of projections is effectively a pre-aggregated query. So it's like a live query, if you will. And these kind of queries, projections are super quick to fetch. So this is why they scale very well on the read side, because they're pre-calculated. And also, they don't have to be the source of truth, so you can store them wherever. Of course, having this has some implicit consequences. The biggest implicit consequence, and that's something that is undeniably true, is that there is no implicit view. If you want to have a view, like in a CRUD situation, you're gonna have to create it. This means there's also separate setup required. If you have a CRUD model, you could basically reuse your decision model for your reads. And for 99% that might work for you, well, more like 70 maybe in some cases. But that means you don't get this for free if you use event sourcing. The benefit of this is that the views are independent, and this is a very big upside. This means that whatever your decision model needs and whatever your read model needs, and the needs of those views, they can be catered to in an independent way. Often this results in the views and the object and the aggregate root persistence to be very simple. We already saw the database schema for the reconstitution. Well, that's just an append-only log. If you use other types of views, just use whatever you need for the read side and cater to it in a consumer. This also means that you can use any type of DB. So while your decisions need to be atomic, ACID compliant, that is really not something that you need to do on the read side. So if you need like a graph database, or you want to use MongoDB because you like MongoDB, I don't know. Or if you want to project it to something entirely different, for example, flush it into a data lake, this is totally possible, and you're not limited by your decision model, and that's the beauty of it. Of course, now we've gone one end up. We've created an aggregate, had some actions, and then we persisted it. But this leaves out one big part, and that's basically the retrieval of the aggregate. So back to terminology, this is what's called a reconstitution. And reconstitution is a fancy word for saying to build something up again. In event sourcing, this rebuilding something is based on events. So a reconstituted aggregate is built up from events, and its job is to be ready to make the next decision. This is done by retrieving all the relevant events. So, as I said before, this is just a subsection that's limited by the consistency boundary, and that's represented as the aggregate root ID. You then create an instance of the aggregate and apply all the events to the model. For this, we go back to the aggregate root repository to add this capability. For this, we need a message repository and a class name. we create a new instance using a named constructor, which is the reconstitute from events named constructor. We pass it the ID and all the relevant events. These relevant events are retrieved from the message repository, where we retrieve everything, and then we yield only the events. So in the end, we get a generator back that just contains the plain events. This again, because the aggregate root only concerns itself with the events and not with the arbitrary metadata that's around it. So if we look internally in the reconstitute from events method, this is what it looks like. We create a new instance of the budget, and then we iterate over all the events and call the apply method on this on the budget. This makes sure that all the states that we normally apply in our record that procedure is now also applied on reconstitution. And this is one of the fundamental parts that when I learned about this really made it click. Us capturing it on the fly and us reconstituting the aggregate uses the same code in order to make sure that it's ready for the next decision. So whether you're operating on a aggregate root directly, or you're operating or you're creating a aggregate root from historic events, we end up in the same state. At the end, we just return the budget that's ready to make the new decision. So now we've gone through this. We've effectively gone through the entire loop of, in a given context, when handling input, a decision is made that has an outcome. But what about tests? Of course, we need to test this. Well, if we reformat that last sentence a little bit, we could say, given a context, when input leads to a decision, then there is an outcome. And this sounds a lot like BDD. And so if you look at event sourcing, these events can also be used in that fashion. So if you flip this around and apply this to event sourcing, you could say, given existing events, and these are our preconditions, when input leads to a decision, so this is handling the input, then we can expect some events because this is the output. So we can use this way of thinking to capture how our tests look. So for example, if we want to test allowing to spend within a budget, it can look something like this. Here we say, given budget was increased by 100, when make purchase with the ID and an amount of 40, then we expect a purchase was made event of 40. We can also do other business rule testings. For example, we can say it disallows to spend over budget, and given the budget was increased by 100, when we and there was existing purchase made of 80, when we now make the purchase, well, now we expect the other type of event. So this is, I think, for me, this is the nicest way to test something. One of the nice things I like about it is you don't see any implementation detail. You just see events, and these are your input and output anyway. So it's like a stable interface to create your tests around. That's pretty powerful. So if you look at event sourcing itself in a sort of broader context, when would you apply this? Well, everywhere where you need to model processes, so something that has a defined start and a defined end, or maybe an undefined ending, but where the time and sequential handling is important, event sourcing is a nice fit. If you have auditing requirements, and for example, me working at Molly, we need to be regularly audited. So having an audit log that you can basically just create by listing all the events is really nice. So if you have such requirements, it might be something to consider. If you need to communicate a lot of change, so for example, if you have a lot of interconnected systems that don't necessarily need to be in sync fully, then having this means of communication towards your integration points is really nice. You can set up a lot of things for retries and fault tolerance that way. It's a natural fit for financial transactions and accounting. That's the space that I work in, so yeah, it's a particular nice fit. Some additional benefits. So insights based on historical events. Now that you've captured everything, you can also look at the past and maybe create something new. If you have your decision model tied to your read model, you basically need to cater for future reading needs from the get-go. And this is really hard and tends to go wrong. If you look at event sourcing, then you can always, to a certain extent, rely on these events to be an input for the future. So at a later point in time, you might have a different understanding of all the events and have a new need for it. So you can create a new view, or you can create other things. Input for machine learning stuff, for example, that's something that you might not think about from the get-go, but if you're event sourcing, this becomes possible. It's super scalable in a sense that if you look at CQRS, and that's already a technique to separate reads and writes from each other, although I really dislike the read and write notation. For me, it's more like I've got the decision side and I've got the representation side. Because event sourcing is all about from the aggregate root around the decision model, and this is just a singular purpose. All the reads can be placed on whatever kind of different medium you need, different types of databases. So scaling reads is incredibly easy. Because event sourcing is based around a lot of message-driven communication styles and architectures, this also means that the write side can be scalable as well. Mostly what you have in these situations is that you know the ID up front. This allows you to also shard incoming things, so you can distribute also your decision side. It's a technique that aligns very well with event storming, which is a collaborative brainstorming tool that you can use to discover business processes. If you haven't checked that out, I encourage you to do so. And lastly, event sourcing, of course, looks very good on your resume. So if you want to be that resume-driven developer, well, now you can. Some considerations. I'll keep this short. Invest in DDD. It is a very nice way to implement CQRS. I would say non-event sourced CQRS is sort of a poor man's CQRS, but that might be something that other people disagree with. Works well with hexagonal architecture. That's something, if you want to create interactions with external systems, hexagonal architecture is definitely something that you should check out, and that might be a good idea for a future stream to explain this as a concept. To sum things up, before I want to put a bow on this and close the stream. With event sourcing, simple tasks are undoubtedly a little bit more work. But then again, difficult tasks are possible, and that's very nice. But there's no such thing as a free lunch. Everything you do in event sourcing is recorded, so are all your failures. if you failed to record something and do that at a later time, now you have two different versions of the events. That's something that you will have to deal with. Your events will also outlive your model, and they will also outlive your current understanding of the model. So everything that you record is something that you will need to deal with in the past. Events are just going to be everywhere. One of the negative consequences in terms of hiring is that fewer people know about it. So hiring for skill is something that is a little bit harder. Reconstitution from many events can become a bottleneck, but there's a solution for that, and that's called snapshotting. It is mostly not needed, but it's something that you can look into. Lastly, I would say it puts software development upside down and inside out, and that can be particularly discomforting. So if you have your known bag of tricks when you're doing CRUD type work, you can basically throw all of those sort of cheat sheets out of the window, and you have to redefine them for what kind of problems you'll be solving in event sourcing. So it's like a classical trade-off where you say, in software engineering, we're not really fixing problems, we're just switching to a different set of problems and hope that we suffer less from those. Lastly, a quick shout out. If you want to get started in event sourcing, please check out EventSauce. It's a library that you can use to implement event sourcing in a pragmatic way. There's a couple of competing projects, and I think that's great because event sourcing is relatively novel technology, especially in the PHP space, but it's really worth to investigate. And the more diverse perspective on the subject, the more that people can learn from it. So I only applaud that. So now I'm going to try to see if we can open it up for questions. And for this, I'm going to have like a 10-second delay, so there might be some silence. Let's see if this works. I see Eric Boy asked, the events store is only immutable until it's not. Well, this is very true. What would you say is the next thing you would like to expand EventSauce towards? Right now, EventSauce is almost at 1.0. I've got a branch up and that's almost ready to go. I think I want to make sure that people can get started with it easier. So first make sure that for the run-of-the-mill frameworks that the integrations are there. Dries already kindly provided integration with Laravel. There's actually two integrations with Laravel, one by the people of Spatie, so that's also pretty cool that you can even choose which kind of integration that you want. And then I want to check if I can do a little bit more on the projection side, so if there's a little bit more tooling that can ease your life, perhaps even go into the space of dashboarding, but that's still in a concept phase. Let's see. I see Daniel Esteban Gonzalez say, I think another downside of event sourcing is that it adds difficulty to be GDPR compliant. So this is true, but there's also, again, techniques around that. People say that you can never rewrite streams. Well, it is technology and you control technology, so of course this is There's also another technique is where you make sure that all the GDPR data is stored separately, and you just use the event store for the events, but have the payloads only be referenced somewhere else. And for this you can use either an in-sync projection or an external system altogether that's mutable. So these things are possible that way. So in a case where you want to delete something, you just delete the reference in the other system. So every bit of your storage is now just, it still holds the reference, but the reference doesn't reference anything anymore. So you're basically GDPR compliant that way. So that's nice. All right, I'm going to look for another couple questions. How do you deal with legacy data when moving to an event source? Well, this is a good one. So there is no one-size-fits-all answer for this. There are some patterns that you can use. For example, one is the autonomous bubble context, and this is a refactoring strategy where you put a new system before an old one, and you basically handle all the new ones and you offload all the old ones to the legacy system. And this works really well if there's a clear defined life cycle. So for example, for processing payments, if you have a legacy system and you want to go from a CRUD-based system to a event sourced system, you would put the event sourced system in front. And because payments only last for a couple of weeks at most, you basically phase out everything over that time. This is of course not really doable for very long-lived aggregates. For that, well, you can always opt to still do it, but that means keeping the legacy platform in place. You could also expose legacy access as a service, where you say you just create an API around the old thing if you need to divert back to it, but just for reads, for example, but never again for writes, which is effectively the same thing as the other pattern I described. One that you often see proposed is a method where you create a sort of a genesis event. I tend to not like that because it's sort of big bang, but it's still a possibility. And this is where you encapsulate the current state of everything into a first event, and after that you model using event sourcing. I see Antonello ask if I can elaborate a little bit more about how event sourcing and event storming work well together. So event storming is a technique where, based on business events, you basically write a lot of things on stickies and place them on a wall in chronological order. If you've got that, then these things are really business centric, and so they're a great way to model your events after. So if you've done an event storming session, and mostly if you look at implementation level event storming, you can just take that and blindly type them out as commands and events, and you've got half your system. You just need to implement the business rules. There's a question around reconstitution that might be slow, and if I have used snapshotting. So I've used snapshotting, but that was only once where there were some developers that were a little bit stubborn, that could not wait to see if normal reconstitution would be fast enough. So for them, I just showed them how you do snapshotting, which is effectively just a pre-aggregated state that you supplement with anything that is of that snapshot version. So you recover all the events with a higher version and still apply that. It's totally possible, but like up to like 100,000 events for an aggregate, you could still just in a blip reconstitute that. Maybe Marco has some cases where reconstitution was a need, but maybe not even. All right. Let's see if I can get some more questions. I see some people mentioning SAP. Well, event sourcing is not that. I too am missing my Belgian beers, Marco. All right. Unless I forgot something. Oh, I see one more. Can you elaborate a bit on the immutable storage being unmutable until it isn't? All right. If you look at the events that you store, you normally don't change these. So unless you have like either a technical reason for it, or you've recorded an event and it was too big, or it was not big enough and you want to combine, or you made something too granular and you want to make it more coarse. And this is where you can apply different types of techniques that either over the wire, so to say, or in memory alter your event stream, or you could even re-persist that. So you can, if you have an event stream, you could also just loop it back into a new event stream and perform some modifications per events. So for example, if you've implemented event sourcing and you forgot to add a message wrapper. So sometimes this is something that is not what people think about from the get-go. Well, for this you can effectively just mutate everything that does not have this wrapper into something that has. So this would be a good use case to mutate the stream. Other things is if you've done a miscalculation, well, you can correct it using another event, but now you have to live with this correction time and time again. So you could do the dirty thing and just correct the stream. All right. I think we're all out of questions. So I think like this is my first time streaming this, so I'm not really sure. I think the stream will be available on YouTube, but I guess we'll see. All right. With that, I would like to thank everybody for joining the stream. Please let me know what you thought. If you liked it, give it a thumbs up or like and subscribe. What is the thing that YouTubers say? And I hope to see you sometime soon. Bye.